Welcome to this video on the Traffic Alert and Collision Avoidance System, or TCAS. We will cover its principles, architecture, and maintenance. The concepts for collision avoidance originated in the 1950s, accelerating after high-profile mid-air collisions. TCAS-2 is now regulated for certain turbine aircraft in Europe. It provides collision avoidance independent of ground stations by interrogating nearby transponders for range, bearing, and altitude. There are two main ACAS classifications. TCASI generates only traffic advisories or TAs, providing range and bearing awareness without vertical guidance. TCAS2 generates TAs and resolution advisories or RAs, providing climb or descend vertical maneuver guidance and coordinating maneuvers via Mode S. The core TCAS architecture includes the computer unit, antennas for full coverage, a control panel, displays, and the Mode S transponder essential for air-to-air coordination. The system uses top directional and bottom omnidirectional or directional antennas. The top antenna transmits in 4 segments to determine bearing. Interrogation pulses are sent at 1030 MHz, and replies are received at 1090 MHz. The control panel allows selection of operating modes. Standby powers the system but prevents transmission. TA/RA is normal operation. TA only inhibits climb commands for specific scenarios. Test initiates the built-in test equipment sequence. The TCAS computer uses several inputs. The radio altimeter is crucial for inhibiting descent commands near terrain. Air data provides barometric altitude and vertical rate. Heading is used to calculate relative bearing. Configuration data determines aircraft performance capabilities. The working principle involves active interrogation. TCAS sends pulses at 1030 MHz, and intruder transponders reply at 1090 MHz. Range is calculated by time-lapse, bearing by directional antenna phase comparison, and altitude is decoded from the intruder's reply data. In high-density airspace, simultaneous replies cause data overload, known as the fruit problem. The whisper-shout solution addresses this by transmitting low power first, then increasing it, along with using suppression and directional interrogation to reduce interference. TCAS defines the protective volume using time, not just distance. Tau is the calculated time remaining to the closest point of approach, or CPA. Vertical tau is the time to reach the same altitude. A traffic advisory, or TA, alerts the crew to a potential collision threat, issued around 35 to 48 seconds before CPA. It appears as a solid yellow circle, with the audio message "Traffic, traffic." The pilot action is to establish visual contact, not maneuver. A resolution advisory, or RA, is a command to maneuver vertically to avoid a collision, issued about 20 to 30 seconds before CPA. It is indicated by a solid red square, with climb, climb, or descend, descend audio. Immediate manual maneuver is required. Coordination between TCAS2 aircraft is achieved via the Mode S data link. If aircraft A determines a climb is needed, it transmits its intent to aircraft B, which then restricts climb and commands a descent. Display symbology distinguishes traffic. Blue squares are other traffic, non-intruding. Blue diamonds are proximate traffic, close, but not a threat. Yellow circles indicate a traffic advisory. Red squares signal a resolution advisory, meaning immediate action is needed. TCAS information is displayed on different units. The IVSI shows traffic rings and RA pitch bands. The EFIS or ND overlays traffic symbols on the map for situational awareness. The PFD shows fly-to pitch cues directly for RA guidance. Resolution advisories are either corrective or preventative. A corrective RA requires a change in vertical path, with climb, climb, or descend, descend audio, demanding active manual input. A preventative RA requires maintaining the current path or avoiding certain rates, with monitor vertical speed or don't climb audio. Oral warnings include traffic, traffic for TAs and climb, climb, or descend, descend for RAs. A reversal RA uses climb, climb now if the initial maneuver is insufficient. Clear of conflict signals the return to ATC clearance. TCAS has limitations and inhibitions. Low altitude inhibition prevents commanding flight into terrain, with specific altitude cutoffs for descent commands. Operational limits include scenarios where no bearing information is available due to failures, and the system ignoring aircraft stall limits. Disadvantages and risks include system blind spots, such as no lateral guidance commands, and being transponder dependent, meaning Tcas cannot detect aircraft without a functioning transponder. Data integrity issues like altimetry errors and garbling also pose risks. Maintenance involves ramp testing using specialized equipment to simulate intruder aircraft scenarios. Procedures include verifying TA and RA symbology and audio output. Precautions include avoiding radiation in the hangar and using antenna hoods to prevent ghost targets.